All right, next up, I'm going to be showing you how to solve the ALEKS problem. Draw one valid Lewis structure, including all lone pair electrons and any form of charges for the compound listed, and assume the atoms are arranged as shown below. So what ALEKS does is it's going to show us the Lewis structure, kind of the atoms are already listed in space, and what it wants us to do is to pretty much connect them or to bond them all together, and to draw lone pairs as well and where they're going to be placed at. So it's some simple rules for this question. First is we got to know how many bonds that each element like to form. We base that on the group that it's in. So it's listed below. We got group 3A, 4A, 5A, 6A, 7A, 8A, and the trick is to just take the number 8 and subtract the group number. So in this case, a carbon is going to be 8 minus 4, and carbon likes to form 4 bonds. Simple enough. So we look at the structure that we have here, and we'll start, and I'll just take this from a left to right approach. Carbon being in group, or hydrogen being in group 1A, typically only forms, and pretty much can only really form, one bond. It's only going to form it with this carbon. And then from here, we're going to look at the carbon to the oxygen. We're going to remember that in this case, oxygen likes to form 2 bonds because it's in group 6A. So 8 minus 6 is 2. And we're going to double bond it right here to this carbon, who overall likes to form 4 bonds. And also, we're going to follow what's known as the octet rule, which means that a element would either like to gain, lose, or share electrons just to make sure that they have 8 flowing within the outer valence shell. So in this case of oxygen and carbon, these double bonds count as kind of 2 each. And then we're going to draw to close, or 2 each. So that's 2, 2. So that's 4. And then we're just going to draw the last 4 lone pairs around it just to make sure that it follows that octet rule. So it has overall is 8. And next up, we're going to focus on carbon. How we said before, carbon likes to form 4 bonds. So we got 1 right here to the hydrogen. We have it double bonded to the oxygen. And then we're going to assign another bond to the carbon right here. And that satisfies the octet rule. So we're going to count them: 2, 4, 6, 8. So it's good, and it has no lone pairs. Next, we're going to move on to the next carbon. First, we'll look at kind of the oxygen below. And again, oxygen likes to form 2 bonds. So in this case, we're going to form 2 bonds right here. And next up, we're going to make sure that it's going to satisfy the octet rule by assigning 4 lone pair, or 2 lone pairs. So 4 electrons around it. So that's going to be 1, 2, 3, 4, and then 2 plus 2, and that's going to be 8, satisfying the octet rule of oxygen. And next, we're going to focus back on carbon. So it's going to form one more bond right here because it likes to form 4. It's going to form to this hydrogen, and it's not going to have any lone pairs. And this is pretty much how your Lewis dot structure is going to look. And then in combat speed, to show you how it's going to look in ALEKS correctly once you submit it, is right here as listed below: single bonds, double bonds, and it's following the octet rule. Again, this is more so stuff that you still learn in your Gen Chem stuff. And, as you go through Orgo, this is just refresher material. But if this helped you or any of your classmates, feel free to like, share, and subscribe to my channel. Thank you.